dear students, let us see how to determine moment of resistance of doubly reinforced beam. So for the doubly reinforced section or for any particular section, why we have to design a beam, for which forces we are going to design a beam. So my question is this: why we are designing a beam? We are designing a beam for maximum shear and maximum bending moment, right? In this case, what about the maximum shear? In this case, the maximum shear is 9.66 kilonewton. Positive shear is 9.66 kilonewton, right? So now this, for the same case, what about the maximum bending moment? The maximum bending moment is 21.98 kilonewton into meter, right? So for maximum shear and maximum bending moment, we are designing our beam, right? Now for any particular beam, first of all, we have to draw shear force and bending moment diagram, right? And for the same beam, we have to determine the moment of resistance of the beam, right? Now, how to determine the moment? That is force into lever arm, right? So how to determine moment of resistance? That is either the tensile force into the lever arm of beam or the compressive force into the lever arm of beam. How it is? Let us see. This one is the neutral axis of beam. Top part of beam, that is in compression. Bottom part of the beam, that is in tension. So either you can consider the top part or you can consider the bottom part. Now for the doubly reinforced beam, here this is applied bending moment mu. Now in the case of doubly reinforced section, our applied bending moment, that is greater than the balance bending moment, right? So for whatever the moment provided by balance section, that is less, right? And applied bending moment is higher. So the additional moment that will be taken care by this imaginary section. So the additional moment that is taken care by this imaginary section, that is equal to the applied bending moment minus the moment is carried out by this balance section, right? So the balance section is same as the singly reinforced beam, right? So the tensile reinforcement is provided on tension side plus the imaginary section, that is the additional reinforcement that is provided on tension side, as well as we have also provided the reinforcement on compression side, right? So the total moment, that is equal to the addition of balance section plus imaginary section, right? Now let us understand the strain diagram. Now for the strain diagram, so here this bending moment that is taken care by the balance section plus the moment of resistance that is provided by the imaginary section. Total compressive force, that is equal to stress into area. Stress is 0.36 FCK, area is B into XU, plus FSC minus FCC, that is stress in steel in compression minus stress in concrete in compression into AC, that is stress into area, right? Same way the stress for the tensile force, the stress is 0.87 Fy and area is AST1 for this particular section, and 0.87 Fy, that is equal to stress into area, that is equal to this area, that is the tensile steel, or you can say that the area of steel for this imaginary section. Now total moment of resistance, that is equal to force into lever arm. So the total compressive force, that is equal to 0.36 FCKB into XU. This is the force multiplied by, you can see this lever arm is D minus 0.42 XU. So the lever arm is D minus 0.42 XU. Force into lever arm plus, now for this imaginary section, the stress is FSC minus FCC into ASC. And what about the lever arm? That is a total depth minus D minus DC, that is the depth of this cover, right? So D minus DC, the lever arm is over here, right? So force into lever arm of this particular balance section plus force into lever arm of this imaginary section. This is total of moment of resistance of doubly reinforced section. Hope my dear student it is clear. If you have any doubt, any questions, you can mail me, you can ask me questions. Okay, so bye bye, मिलते हैं नेक्स्ट लेक्चर में.